So for this problem, let us define our coordinate system to be like in the following diagram, where our origin is in the middle of the straight edge of the semicircle. So then, by symmetry, the center mass should lie along the negative y-axis. So to make this problem a little simpler, let us call the mass per unit area sigma. So that's given by the total mass of the semicircle, which is big M, divided by the area of the semicircle, which is half pi big R squared. So that means that sigma is 2 times big M over pi times big R squared. So then the first moment in the y direction is given by the integral of y dm, where dm is an infinitesimal mass element. Now, since we know sigma, we can calculate dm, which is just sigma, the mass per unit area, times dA, where dA is an infinitesimal area element. So this means that the first moment in the y direction is the integral of y sigma dA. Now, in this video, we will be calculating this integral using Cartesian coordinates. In the next video, we will be using polar coordinates to calculate the integral. So, in Cartesian coordinates, let us consider a slice of the semicircle of width dy. Now, to calculate the width, note that the area of the semicircle, or the area of a circle in general, is just x squared plus y squared is equal to the radius squared, which is big R squared, which means that x is equal to the square root of big R squared minus y squared. Now, x is just the distance from the horizontal distance from the origin to the side of one of the semicircle. So that means that the total width is twice that distance. Therefore, dA is equal to the height, which is dy, times the width, which is 2 times square root of big R squared minus y squared. So this means that the first moment, y direction is the integral, and we're integrating from y equals negative r to y equals 0, and we've got y sigma 2 times big R squared minus y squared dy. Now, let us substitute in u equals big R squared minus y squared to make this simpler, which means that du is equal to negative 2 times y dy. So our integral becomes, well, when y is negative r, u is 0, and when y is 0, u is big R squared, and we've got 2y dy is just negative du, so we'll put that in brackets over here, and square root of big R squared minus y squared is just u to the 1/2. Since sigma is a constant, we can take that out. So that simplifies down to negative sigma 2 over 3 u to the 3 over 2 evaluated from 0 to big R squared, which is just, now sigma is 2 times big M over pi big R squared times 2 over 3. And we substitute in big R squared to u to the 3 over 2. We get r to the 3rd. So that all simplifies down to negative 4 big M over 3 pi big R. So that's the first moment. This means that the center mass in the y direction is just the first moment in the y direction, divided by the total mass, which is big M. So that means that divided by big M is just negative 4 over 3 pi big R, which is approximately negative 0.424 big R.